Jai Hind everyone. Myself Achin Pandey, as an assistant professor in Department of Information Technology at AKGEC Engineering College. Today I am going to present my topic implementing polymorphism, and here we could discuss the virtual functions and all. Like, so what is polymorphism? And what is polymorphism? Actually, polymorphism is a concept, and that concept is implemented by depending on the what type of polymorphism, either it is compile time polymorphism or runtime polymorphism. This concept are can be implemented by implementing function overloading, or you can sometimes it is or function overriding. Okay, actually compile time polymorphism could be achieved by function overloading. So basically function overloading is a technique which implement compile time polymorphism. Similarly, function overriding and basically the virtual function, it is a technique, right, tools, and by that we could implement the runtime polymorphism, right. So here we will explore the polymorphism, and we will see the virtual function. Okay, so we see the compile time polymorphism. It is also called as a static or sometimes early binding, because a compile time polymorphism can be seen at compile time, right, and this compile time polymorphism can be implemented by function and operator overloading. Similarly, runtime polymorphism is also called late binding, it is called called dynamic binding or late binding. It is not early binding. This is wrong, right? This is compile time polymorphism is a early binding, but runtime polymorphism is a not early binding. It is late binding. Sometimes it is called late binding, right? Okay, because this will bind up to the till the runtime, and which comes after the compile time. Okay, so example is virtual function. We will see. Okay, so first we have here discussed compile time polymorphism, and that could be implemented by function and operator overloading. So what is function overloading? Function overloading means one function could exhibit different behavior, I mean different code, depending on the type of parameter or argument which is passed to that function. So if we make change either by making the type, right, or even number of argument, if it changes and the code changes, then this is called the function overloading. Similarly, this could be achieved by even the operator. We could make operator as a function, and that's why it is called overloading. Overloading means the same function, and if we make change in the number of argument or type of argument, this could have different code, and that's why we could say that this could be the overloading. For example, we could see suppose we want to calculate area, and let's say if we passing just for example, let's say a function area, and we make a function, we pass one argument to this function, so they could calculate the area of circle. If we pass, say for example, two argument, 1 and 2, right, and if we write the code of the area, so say this we could calculate the area of rectangle. Similarly, if we pass three argument, okay, 1, 2 and 3, and they could calculate the area of triangle. So area is the same function, right? For example, in real time we could take example of shape. If we pass say one argument, it could be circle. If we pass two, then the shape could be say rectangle or box, and if we could pass 3, then this could be triangle, and so on, right? So this area function or even shape function, we will call, or we will say that this function has been overloaded. Okay, so the compile time polymorphism is achieved by overloading that function. Here basically we will mainly focus on the runtime polymorphism, and that is particularly we will talk about the virtual function. So what is virtual function? Okay, so before knowing the virtual function, we would have to know what are the pointer to the class, right? How we could make pointer to the object, right? So C++ allow base class pointer to point to derived class object, right? We could have base class, we could have derived class. So by making or by just if we make the base class pointer, this base class pointer would have the capability to point the base class as well as its derived class, but not the vice versa, right? For example, here we have a base class and here we have this derived class derived itself, which is a single inheritance. This becomes the base class. Okay, so if we make the base class pointer, right? Okay, so P1 in P1 even we could here we can see that in P1 even we could write the address of the derived object, but not vice versa. We cannot create the pointer to derived object, right? I mean, this is say derived class object. If we say make a pointer of this derived class, and we cannot give the address directly to the base class, right? So, but by using our pointer to base class, they could I mean refer to the derived class also, right? Okay, so using a base class pointer pointing to a derived class object, we can access only those members of the derived object that were inherited from the base. It is different from the behavior that Java shows. Okay, Java we could not do like that. Okay, so you can get Java like behavior using virtual functions. So this is because the base pointer has knowledge only of the base class. It knows nothing about the member added by the derived classes. So just see the program here, pointers to derived classes. Okay, here a class, and that is the function. Here we have used so, and we have different class, derived class, and its superclass is base, right? Again we have so we have the same function, means the case of function overloading. So which one gets, you know, what will be the output? Similarly here we have making the base class, right? And v1 dot so, I mean the same function, all the function call here is statistically bound. We have made the base pointer, right? And we are making the so. So the pb dot so will simply pb means we are making the address of d1, and pb is nothing but what is pb? pb is basically base class pointer. So here we could give the address of base, and this if we make use of this pb and we want to, you know, call the so function, so it will give only the base, it will not give this one. Okay, so all the function call are here statically bound. So while it is permissible for a base class pointer to point to a derived object, the reverse is not true, right? So we can perform a downcast with the help of typecasting, but should use with the caution. Okay, so pointer to derived class, here again like we have pointer to base class, here we could have the pointer to derived class, and by, you know, typecast we could do downcasting even, right? So pointer to derived, in fact using typecasting we can use pointer of any class to point to an object of any other class. So by making the typecast we could do this, but the compiler will not complain. During runtime the address assignment will also succeed. Okay, so further these are some important point on inheritance. In C++, only public inheritance support the perfect is a relation. In case of private and protected inheritance, we cannot treat a derived class object in the same way, okay, as a base class object. Public member of the base class become private or protected in the derived class, and hence cannot be accessed directly by others using the derived class object. So if we use a private or protected inheritance, we cannot assign the address of a derived class object to a base class pointer. Okay, so let's see the introduction to virtual functions. So what we have introduced, so we just know the base class pointer and derived class pointer, and we have seen that we could even downcast using the derived class pointer. So virtual function is nothing but it is a member function which is declared within a base class, and this could be redefined by a derived class, and this redefining is called function overriding. So it implements the one interface multiple method philosophy that underlie polymorphism. The keyword virtual is used to designate a member function as a virtual. It supports runtime polymorphism. So virtual functions support the runtime polymorphism with the help of base class pointer. Okay, because base class pointer have the capability to store, to point the base class object as well as the derived class object, right? Okay, so while redefining a virtual function in a derived class, the function signature must match the original function present in the base class. So we call it overriding, not overloading. So when a virtual function is redefined by a derived class, the keyword virtual is not needed, right? Virtual would not be needed when it is used by the derived class. The virtual of the member continue along with the inheritance chain. A class that contains a virtual function is referred to as a polymorphic class, right? So the class which contains the virtual function, it is called polymorphic class. For example, let's see this example. Here we have used the function so, right? And in base class we have mentioned the keyword virtual. Okay, derived class, okay, so function has been used. Now we are just going to create a base class object b1 dot so. It will print this when we make the object b1 dot so. So what is so function? So function will show simply base. So it will say from base, right? I mean the output will be base. Similarly, we have make a derived object d1 dot so is will of course so this one derived. Now we are making a pointer to base class and we are giving the address b1. So once we make pb dot so, it will show of course base, but once we write pb is whether equal to address of d1 means we are pointing to the derived class objects, and once we make this pb dot so, it will not show the base but it will show the derived class. Why? Because we have already mentioned it a base class as a virtual. Okay, so this is the difference. We can say if you want to omit the body of a virtual function in a base class, we can use pure virtual functions, right? Like here by omitting we could write the just simply 0. So it makes a class as an abstract class. We cannot create any object of such classes. It forces derived class to override it, otherwise they become abstract too. Okay, so pure virtual function helps to guarantee that a derived class will provide its own redefinition. We can still create a pointer to an abstract class and all. So when a virtual function is inherited, so is its virtual nature, we can continue to override and all this. Okay, so finally we have seen that runtime polymorphism is not automatically activated in C++, right? We have to use virtual function and base class pointer, right? By making base class pointers, we could override the function in a function, the same function which is used in the base class, but return the virtual keyword. So we can still create a pointer to an abstract class because it is the heart of the runtime polymorphism. When a virtual function is inherited, so is its virtual nature. Okay, we can continue to override virtual function along with inheritance hierarchy. Okay, so we have to use virtual function and base class pointer to enforce and activate runtime polymorphism in C++, but in Java runtime polymorphism is automatically present. So this is one difference, that in Java it is automatically, but in C++ if you want to enforce runtime polymorphism, then we need to call as a virtual function. Okay, so this is what we have. So in implementing polymorphism could be in a two way. One is compile, second is runtime. Compile time polymorphism could be by overloading, either it could be function or either it could be operator, while runtime polymorphism could be achieved by using virtual function, right? And intelligently make the use of pointer to base class, right? So this is how we could do that. Okay, thank you everyone.